Are we good? We know our sine, cosine, and tangent. All right. Here's where our notes begin. 2 vocab words. I mentioned them, angle of elevation and angle of depression. Angle of elevation. The angle of elevation, that's your first blank, is always measured from the ground up. And it is always, always, always inside the triangle. From the ground up and inside the triangle. They're telling you, as you see in this diagram right here, this is an angle of elevation as if you're standing here. This can help if you want to draw. You're standing here, you're looking straight, and then you look to the top of this beautiful blue tree. As you look up, that's your angle of elevation. That's what that means. Is that clear? You can only, it's like an elevator. You only go up. Elevator that only goes up. Okay? It's a broken elevator. The angle of depression, it's our second vocab word, angle of depression. This one's a little bit tricky. Pay attention. Angle of depression is always on the outside of the triangle. Outside? What's it doing out there? The outside of the triangle is never, 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 if they say angle of depression, never on the inside. Always on the outside. So they're telling us if there's a boat, this is a sad little boat, that is a boat. You're up here in a lighthouse. Hey guys, you're up here in a lighthouse looking straight out. You look down at that boat. That's your angle of depression. You're at the top of something here, looking down. That's your angle of depression. See how up here you're looking straight and then you look to the top of something? Here you're looking down at something. That's the difference. And make sure you know that this is on the inside of that triangle and you have to label this on the outside. Okay? Last little thing that is actually kind of interesting, and I said it's like hashtag TBT today because we're going back to a little bit of geometry. Right here, let me use a different color. What would you call these 2 green lines? Parallel. Yes, you said it. That's exactly what I wanted to hear. Parallel, and this is like a transversal. Does anyone remember that word? Sounds familiar? Well, do we remember that opposite interior angles are equal? Yeah. So doesn't that make this theta too? So our little fact down here, this tells us that the angle of elevation is actually equal to the angle of depression, right? Doesn't our diagram show that? Isn't that neat? I abbreviated, but I would maybe write it out if I were you. So does that make sense to you that this angle of depression is the same as this angle in the triangle? That's why we're saying they're equal, okay? They're just described differently, different pictures maybe. Now I want to talk to you about what do you do if you have an angle that's outside of a triangle? It's not in there. We can only use the trig functions when we're talking about angles inside the triangle. So what do? We have to figure out an angle inside that triangle using what we know. So there are 2 things we can do. The first being complementary angles. What is that? Is that corner right there? How many degrees? 90. It's a corner. It's 90 degrees. So if we know theta, let's say theta is 35. Doesn't that mean that this angle has to be 55, so it adds up to 90? It has to be. So that gives us an angle inside the triangle, right? Or, number 2, different way to look at it, is what we just talked about, the transversal. Opposite interior angles. So either way, whether you prefer one or two, you have an angle inside here or an angle inside here. But either way, you need to get an angle inside of the triangle, or else you can't use the trig functions. So if you ever are given an angle of depression, use one of those two methods, whichever one you prefer. Does everyone understand angle of depression, angle of elevation? We understand how to get it inside when it's an angle of depression. Yes, good. Let's try an example. All right, it's telling us a 12-meter flagpole casts a 9-meter shadow. Find theta, the angle of elevation of the sun. So the first thing I like to do is draw a picture. My flag is 12 meters. Oh. 12 meters. And it's casting a shadow this way, right? Shadow's on the ground, this way, 9 meters. I'm just depicting exactly what the problem is telling us. They're saying they want us to find theta, an angle of elevation of the sun. If the sun's up here, say we're down here, wouldn't that angle of elevation be us looking up at the sun? Right? Does everyone see that that's theta? That's our angle of elevation? Okay, next thing. We need to figure out what trig ratio works for what we're given. We have this angle. We have something opposite of it. We also have something adjacent to it. What does that leave us with? Anyone? Tangent? Is that what you're going to say? Tangent? So I'm just going to write this so that you start to understand that maybe this is helpful to write down. We had an angle, and we had something opposite, and we had something adjacent. And that's how we deduced we needed tangent. Now that we know that tangent of theta is what we're going to use, we need to plug in what we have. We don't have theta, so that stays. That's our unknown. We do have opposite, and we do have adjacent. Yesterday we did this. How did we get rid of that tangent? How would we do it? Inverse tangent. Yes, theta equals tan inverse of 12 over 9. This is where calculators come in if you want to pull it out and see what we get for tan inverse of 12 over 9. I have an answer. Let's see if yours matches. I'm hearing numbers, what? 53.1. Anyone else have an answer confirming? Alex, you're confirming? Do you have any more confirmations? Dan? Well, I'll go ahead and say it. He is right. I did it 0.13, but that's fine. But we aren't quite done yet because this is a word problem, meaning that these numbers have meaning. They mean something. So to end a word problem, you always need to end with a complete sentence. So I'm going to say, and you should also say, the angle of elevation of the sun is 53.13 degrees. That is our answer. As a little bit of independent practice before we do our fun activity to end class, I want you to try example 2. I'll walk around, I'll help you out if you need it. This is example 2. Make sure you kind of follow those guidelines that I talked about as I went through. They're on the sideboard, word problem guidelines. I drew a picture, I wrote a verbal model, I figured out what I knew and what I didn't know, and then I wrote and solved. Seeing a lot of right answers. The right answer is, I'm just going to write theta equals 21.8. That's what you should get. Yours should be with picture, with labels, with complete sentence. I'm just writing this so that you know the answer. Is everyone okay with this? Does everyone see where I got this? If not, I can draw a picture. Let me know. No? You're just experts? You think so? Well, that's great, because we're about to do some group work with more of the practice problems. Oh, I need this. So I split you guys up into groups. Why is this so hard for me to get? Check out your groups. Before you get into your groups, let me explain a little bit. Next to your group is a number. That number is associated with which practice problem you are doing with your group. You're going to do it on scratch paper first and have me confirm that you did it correctly. And then you get a giant piece of sticky note paper like on the backboard from last period, and you get to put it all on that. The poster requirements are over there on the sideboard. Each of those stars indicates that a different person should do one of those, because those are the 3 major parts. Okay? Are there any questions? Yes. Oh no. If you want to, you can do it by yourself. If not, you can join another group. It's up to you, honestly. You can pick any group because, yeah, that would happen with the 2 people. But go ahead and move into your groups. Start working on the problems together. I'll walk around and make sure everyone's on the right track. What do you want to do? It's up to you. Okay. Could you pause? Because it's not up here. Oh yeah, go for it.